Good afternoon, everyone.
Good afternoon, sir.
Afternoon. So, shall we start? Many of you have requested, since this is a Friday, so we wanted to finish your prayer and come back. So that's the reason I waited for 15 minutes or to have come back to the class. Shall I start? Are you able to see the screen? Is the screen visible now? Yes. Am I audible? Guys, am I audible?
Yes, sir.
Okay. Shall we start? Okay, and since no one has responded, I am hoping that my screen as well as my audio is clear to you. If you have any disturbances in these two, you can immediately stop. Okay.
So your presentation is visible, but your voice is too low, sir.
Tool. Okay. I think it's because of fan. Switch it off.
And there is also some
Yeah,
disturbance,
yeah,
sir.
yeah.
Which is
Good.
supposed to stop there.
Hope everything is clear now. Man. Am I audible clearly? Am I audible, man?
Yes, sir.
Yes, sir.
Ah, thank God. Okay. So now this will start the eighth experiment, which is known as the journal bearing. Okay. So the whole experiment goes in this way. Okay. The main aim of this particular experiment is, see, there will be a shaft and there will be a journal like this, right? For this journal, all this what you are seeing now is the gap between the shaft and the journal. Okay? Shaft and the bearing. Journal is nothing but your shaft. So this is the difference in gap between your shaft. So shaft would be this particular thing, which is a long thing like this, and the holding or the shaft which is supporting the thing is your bearing, which is this. Okay. Now, the pressure when you measure across the circumference of a shaft, suppose see. So this is the circumference of the shaft. If you measure the pressure at every individual point, say this point, this, and this, according to theoretical, the pressure distribution across its circumference would be same. That means whatever the pressure which is distributed across the journal bearing is same like this. Okay, that means it has a uniform pressure distribution across the bearing. But in reality, what happens? This varies. It means at some points it will be having a very high pressure. At some points there will be even no pressure acting. So there would be an ununiform distribution of pressure across the journal, across the shaft. And that is the thing which is of main focus of this particular experiment. So what you will be doing is, in this experimentation, you will be drawing a pressure distribution curve along the shaft circumference or along the bearing circumference and try to analyze how it differs with actual pressure distribution, which is theoretical pressure distribution. So theoretical pressure distribution says it is a circle, but actual pressure distribution says it is something else. So we'll be having a comparative study between these two pressure distributions, that is theoretical and experimental. And that is our main intention of doing this particular experiment. And how you'll be doing this in the sense, for that, what we'll be doing is around this bearing, I'll be taking numerous tappings like this. Not numerous, to be precisely 12 tappings have been taken like this. Okay. All these 12 tappings are fitted with the pipes like this. Okay. So all these tappings are taken up with the pipe. Individual pipe it might be. Okay. So these all tappings are taken out with a pipe, and all these pipes are arranged in a sequential manner so that you can judge for individual pipe there will be a drift in the oil levels, right? So you can observe what is the oil level for this pipe and what is the oil level for this pipe and considerably measuring those things. And that is how the experimental setup is built up. So just for now, you understand at, to be precisely, at 30-degree intervals, at every 30-degree intervals, there would be one tapping which is taken out like this. Okay, tapping in the sense it is just a hole which is taken out from the bearing, and for that particular individual tapping you are connecting a numerous tubes. Okay, all these tubes are aligned in a straight order in a long board. So in order to measure the height, so from this particular height, whichever it is there, we'll be calculating its pressure and we will be plotting it around the circumference. That is how with the experimentation. Let us see how in reality it looks like. So you can see here. Uh, are you able to see it? Okay, fine. So This is the bearing. Around the bearing, you can see the 12 pipes which is connected around the 30-degree angle measurement. For every 30 degree, there is a single pipe connected, and all those pipes are arranged in a board like this. I'll be just playing this video, and in order to run this, there is a motor over there, which is again connected to a dimmer stat, where you need to switch on the motor and run it. Okay, just observe it. So all these pipes are connected to a board like this. Okay, and every individual pipe is being mounted with a scale also in order to make it convenient to read the height of those pipes, oil level. Okay, and that is how it is there. Okay, now what is the procedure? So first you have to fill up this. There will be an oil tank, if I am right. Okay, there will be oil tank. Yes, here it is, the black color one. The black color one is the oil tank where you need to fill the oil, and that particular oil should be matched with the bearing oil. You have to ask the instructor which type of oil it is, whether it is SAE 40, SAE 30, or SAE 20, which type of oil it is, and all these are industrial grade. So you have to ask a particular oil, and that oil you have to fill up in the supply tank here. Okay, that is your supply head. That means from that particular height, you are supplying the oil to the general bearing. Okay, so that is the first procedure, filling up the oil. Once you fill it up the oil, you have to start the motor and keep the bearing running for about half an hour. So for about half an hour, you should keep the bearing running, and you should not take the readings in between. Why? Because you need to allow the oil to heat up and maintain its temperature uniformly. That means you are waiting for its steady state condition. No more fluctuations in the oil levels. So all those things has to be achieved. So that is the reason why you wait for 30 minutes. That means for 30 minutes, you just keep it running, and oil attains its own temperature and own heights in the respective columns. Then you are in a position to take the readings. So how do you take the readings? You can observe the different oil levels in the different pipes over there. In particular pipe, you have to take down whatever is the oil level. So once you have taken down that reading, how it will look is like this. Okay, so this is the thing. What is P naught here? P naught is nothing but the supply oil where the high supply oil tank was placed there. That is your P naught. Okay, and individual pipe for 30 degree. So I have told you, right? For 30 degree, what was the pressure head? From that reading will be noted down. For 60 degree, the oil has not reached, so it is 0. For 90 degree, it is 300. Similarly, up to 360 degree, you will note down all the parameters. I mean to say all the oil height levels. Now what you have to do, you have to calculate the net head difference. In order to calculate the net head difference, what you'll be doing, whatever the head which is available in the particular pipe minus your supply head. So you have to subtract the head available in the particular pipe minus your supply head, then you'll get the net head, which is this. It might be negative or positive depending upon the distribution of pressure. Okay, so this is the net head which is available at that particular pipe. And again, you'll be getting the readings in different segments, like this 120, it is this much, 150, it is this much, and so on. Okay. Now, coming to the graph, you have to draw the graph. How to draw a graph? Let us see. Okay. First, you have to fix the origin, and you have to divide this graph sheet into 30-degree segments. That means this is 0, this is 30, 60, 90, and so on. So you have to divide the whole graph sheet like this into 30-degree segments all over the graph sheet. Once you have divided it, you have to name it. So this is 0, this is 30, this is 60, and this is 90, and so on, up to 360 again back. So you have to just name the whole things. So this particular segment is there. No, this is the linear scale. So upon matching the respective scale, seeing these readings, you have to mark the things. So that is indicated by the red line, which is here. Okay, you have to mark the things. Suppose in 90 degrees it is so and so. At this particular degree it is so and so. At 180 it is such. Just you have to mark all the points on the graph sheet which is corresponding to the total head. So once you have marked all the readings, what you have to do, you have to join this so that you will get the pressure distribution curve. So this is what you get, the pressure distribution curve. Okay, and at one point it will break away from the normal curve. That means at this particular point, if you observe what is happening in this particular point, it is totally away from the region. So you have to take it back to the origin like this and measure this particular angle. At which angle does it breaking away? So it is breaking away at 30 degrees. So for that, 180 minus theta I have to do. So the theta is nothing but this particular angle. So it is 180 minus 30, it is 150. That is your phi max. That will be helpful in the problems. Okay, so this is the pressure distribution. If you observe carefully, there are two lines drawn, two graphs drawn. Number one is, which is in red color. Just a minute. Okay. So if you observe this, or what I was telling is there are two different curves. The one is in green. Okay. So there were two curves here. Number one is the green color one, which represents the actual one. You can observe it as totally a beautiful circle. But when it comes to the actual one, so this was the theoretical one. When it comes to the actual one, it differs along the circumference. So totally it differs along the circumference. You can have a comparativity of these two parameters. Now, we shall look into the calculations. Eccentricity ratio is nothing but your n. You can have to remember this formula in order to calculate your eccentricity ratio, which is cos phi max, that is equals to minus 3n divided by n square plus 2. Phi max will be obtaining from the graph, if you remember. So from the graph it is 150. So the same thing you'll be substituting here. So the only unknown would be n. So since it is a quadratic equation, you can use either your calculator or your mathematical principles to calculate it. Using a calculator, it will give you the answers very fast. So use that. So we'll be getting two answers, eccentricity ratio 2.7 and 0.7. So you know that eccentricity ratio should always be less than 1. It cannot be greater than 1. That's why you are considering this value and you are neglecting this value. So your n value was 0.732. Similarly, next, sum of Fields constant you are going to find out. In order to find out, this is the sum of Fields expression. P minus P naught is equals to minus K into sine phi into 2 plus n cos phi divided by 1 plus n cos phi whole square. So in this particular expression, phi, which is already known, P minus P naught, you'll be just calculating it here. That is equals to rho g h. Rho is, substitute the value of rho g and h, you'll be getting the P minus P naught value. Similarly, so cos phi will be knowing from the graph. N you have just calculated in the previous step. So the only unknown in this particular expression would be K, that you can calculate it as minus 0.03. Load on the bearing. So since you are not adding any load on the bearing here, So generally, if the external asks, so you must add certain weights in the provisions provided. If not, it is fine. So where weight added is 0, dry weight without the oil is nothing but 452. That is the load on the bearing that you can measure it up. Now, mean positive pressure. So mean positive pressure in the sense you have to go back to the pressure columns. You have to search for in this pressure readings how many positive valves are there. So this is the positive valve. All these are positive valves. So you have to take a mean of all these valves in order to get the mean positive head of this particular journal bearing. And the last is the load carried by the projected area. So in order to find that, it is h rho into 2 RL, where h is your height, datum height, and rho is your density, and 2RL belongs to the bearing parameters. I think I have not discussed about the bearing parameters. So here are the bearing parameters. The diameter of the journal. So journal is nothing but your shaft, okay, and the bearing is nothing but the whole thing which is holding that. So the diameter of the journal is 50, and the diameter of the bearing is 55, which will be given to you in the form of observations. So the clearance is 5 mm clearly. So if you subtract these two, you'll get what is the clearance. The width of the bearing in the sense, what is the total length of the bearing like this? Okay, this particular length is nothing but 70 mm. Weight on the bearing with attachments, that is 226. Okay, supply head is 740 because the supply head tank is at the 740 mm from the ground. Okay, shaft speed is 1500. So if the external asks you to calculate the pressure distribution at a different speed other than 1500, you have to just use the thermostat and change the speed to which is our required. Suppose if you ask for 800, you have to just set the speed for 800, wait for half an hour, and then take the readings and plot the pressure distribution. So this is all about the experimentation, guys. It's I think it's very easy. Okay, the thing is you have to come here and note down how literally to take the readings from the journal bearings. Okay, any doubts? Any doubts?
No, sir.
Understood. If you have any doubts, let me know, man. Okay. Do you have any doubts, man? Okay. So we should move to the attendance then. So, okay, give your attendance. Abhideep G. Shetty, Achintya,
Yeah, sir.
Afseen, Akhil, Anand.
Sir, Afshin.
Okay, Anand, Be attentive, man. Just give the attendance very fast. Okay. Azim.
Present, sir. Present, sir.
So,
Azim present.
yes. Sanjit
Sir,
Jain.
Akshin present, but
Present, sir.
I've seen. I have marked it. Sanjit Jain. I have marked it. Chinmay.
Present.
Present, sir.
Darren. Darren. Next is Dinesh.
Present, sir.
Gagan. Gautam. Hare Krishna.
Present, sir.
Joel. Kishan. Lanston.
Present, sir.
Ish. Muhammad Aqib.
Sir, Manoj present, sir.
Tikar.
Present, sir.
Okay. Rilwan.
Sir, Nabil
Present,
present.
sir. Sir, Rilwan present.
Sir, Nabil present.
Okay. Nabil. Salil.
Sir, Sahil. Sahil present, sir.
Okay, Sahil is it. Okay, fine. Hamish. Nishan. Nitesh Salian. Sodan Shetty. Pavan Kumar.
Present, sir.
Yes, sir. Yes, sir.
Yes, sir. Nishan present, sir.
Nishan. Nitesh Salian. Okay.
Sir, present, sir.
Pawan present,
Okay.
sir.
Pavan present. Prasanna.
Yes, sir. Yes, sir.
Prateek.
Yes, sir. Yes, sir.
Sir, Rahul
Rajesh.
present, sir.
Okay, Rahul, Rajesh, Rakesh. Ritvik.
Sir, Rahul present,
Yes,
sir.
yes, I am. Okay. Sachin.
Present, sir. Ritik present.
Okay. Sachet.
Yes, sir. Present.
Yes, sir. Yes, sir. Sajid present, sir.
Okay. Next, Sandesh.
Sandesh, present, sir.
Sharat.
Present, sir.
Shashank Wakle.
Present, sir.
Shetty Chetan. Shetty Sanket. Subramanya.
Present,
Sudhindra.
sir. Present.
Present, sir. Present.
Okay. Sudhindra.
Present, sir.
Sushant.
Present, sir.
Vasant. Yes.
Present, sir.
Next is Vikas Naik.
Present, sir.
Vivek Shetty. Suhaib.
Suhaib present, sir.
Next is Aja Arjun. Rakib.
Yes, sir. Present, sir.
Prasad.
Arjun present.
sir.
Arjun present.
Okay, Arjun Pradeep present. Okay, Abhijit.
Present, sir.
Akil Samad. Siddharth K.
Present, sir. Siddharth present, sir.
Okay, Saurav. Harris.
Present, sir. Harris present.
Okay. Bharat Kumar Rai. Sohail. Nehal. Muhammad Nasif.
Yes, sir.
Okay, guys. So we shall meet up in the next week again. In that experiment, we will deal with balancing of rotating masses. Till then, enjoy yourself. Be happy. Keep smiling. Take care.
Sir, Sandesh
Thank you, sir.
Palankar.
Sandesh, mark
Thank you, sir.
Yeah.
Sorry, sir, can't hear you. Yes, sir.
Mark ಮಾಡಿದ್ದೀನಿ Sandesh.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
Yeah.
Hello, sir. Manish.
Manisha. Manishma. Sorry.